Hello and welcome back. We'll continue looking at quadratic equations, and one quadratic equation that comes up quite a bit is one that's going to be a perfect square. So we should recall that if you take the square of a binomial, we have a nice formula for this: a squared plus 2ab plus b squared, where you're squaring a plus b. So sometimes we're just going to see the first part of this. We're just going to see a squared plus 2ab in some form, and if we recognize it, we can add a b squared and everything will factor really easily. So this is called completing the square, and essentially what we'll do is we'll try to recognize when we see something like this so that we can add a b squared to it and make it factor really easily. So how do we recognize this? Whenever you have something of the form x squared plus b times x, this is going to be the form that we're looking for. And what we'll do is we'll add this particular number. We're going to take b divided by 2 and then square the whole thing. And what will happen here is the following. If we add b over 2 quantity squared, this happens to be a perfect square, and this is going to be x plus b over 2 quantity squared. When we have a perfect square, it's really easy to deal with since it's already factored, and we can just use the square root principle to solve this. So let's try a couple of these. So just using our formula, whenever we have an x squared plus a bx, we can complete the square. So here we have an x squared plus bx. So here b is going to be 6. I apologize, my b's also look like 6s. So we want to add b divided by 2 squared. So b divided by 2 squared is going to be the same thing as 6 divided by 2 squared. Simplifying 6 divided by 2 is 3, and we're squaring that, so that's 9. So we're just going to add 9 to this expression. So again, we'll just add that b over 2 squared. And as it happens, this is going to be x plus something squared. What's that something? Let's b divided by 2. Well, we already solved for this. This is going to be 3. So if we were to FOIL this out, x plus 3, and we FOIL this out and we squared it, we would get back to our original equation. Let's do some more. So here we've got x squared minus 5x. Okay, so if we want to complete the square, we identify what b is. B is now negative 5, since this is the coefficient of x. And if we take b squared divided by 2, we'll have negative 5 divided by 2 quantity squared. This doesn't simplify, so I'm just going to square everything. So when we square a fraction, we can just square the top. So negative 5 squared is 25. Notice it's a plus 25. And 2 squared is 4. So this is my b over 2 squared. So when I complete the square, I'm going to take my original expression, add my b over 2 squared, and ultimately this will factor perfectly into x plus b over 2. So here's b. So one way to write this is going to be x plus negative 5 divided by 2 squared. Now negative 5 divided by 2, this is a negative number. So another way of writing this is going to be x minus 5 over 2 squared. It doesn't matter if the negative sign is up here, just on the 5, or if we pull it out front and just subtract the whole fraction. I think this is easier to work with and to think about. And let's try this with one more. So here we already have a fraction in here. So again, we have to identify what is b. B is going to be 2/3. And now I want b divided by 2 quantity squared. So this is going to be 2/3 divided by 2 squared. When I'm dividing by a number, dividing a fraction by a number, I'm going to turn the bottom into a fraction. 2 is the same thing as 2 over 1. And instead of dividing by a fraction, I'm going to multiply by the reciprocal. So instead of dividing by 2 over 1, I'm going to multiply by 1 over 2. Remembering, everything is squared. We can't forget that. So here, 2/3 times 1/2, 2's cancel, and I'm left with 1/3 squared, which is 1/9. So there's a lot of work, but we simplified it quite a bit to 1/9. So here, when I complete the square, I will take x squared plus 2/3 x plus 1/9. And the whole reason we did this is because now this factors perfectly. This is going to be x plus b over 2, which we found is 1/3 quantity squared. And again, if we were to FOIL this out, we would get back to this equation over here. Completing the square is really nice for solving equations. So let's look at how we would do that. So what we'll do is we'll pretend that we'll start with a quadratic equation. Ax squared plus bx plus c is equal to 0. The first thing that you'll notice is that in all of our examples, we just had an x squared by itself, an x squared by itself, and an x squared by itself. We don't want this a multiplying the x squared. So if it's anything other than 1, we'll just divide everything by a to get rid of it. So now we have no a out in front. Next, in order to complete the square, we had to have something that was x squared plus something times x. So we will make it look like that, complete the square, and solve. And this will be easier using an example. So let's look at x squared plus 4x minus 1 is equal to 0. First and foremost, let's identify each of our coefficients. A out front is 1. This is just 1 times x squared, which is nice because I don't have anything multiplying that x squared, so I don't have to worry about anything. B is 4, and C is going to be negative 1. So we already have a 1 times the x squared, so we don't have to do anything like that. Next, in order to complete the square, I've got to have something that looks like x squared plus something times x. Well, I already do. However, I have this negative 1 on this side, so I need to get rid of that by adding 1 to both sides. So all I've done is I've added 1 to both sides here, and now I can complete the square. So on this left-hand side, we've got x squared plus 4x. B is equal to 4. So in order to complete the square, I need b over 2 squared. B is 4. If I divide that by 2 and square it, 4 divided by 2 is in fact 2. And if I square that, it is itself 4. So what I want to do is I want to complete the square by adding 4. This is the number that I came up with. However, whatever I do to one side of the equation, I've got to do to the other. Okay? So I just add that b over 2 squared to both sides of the equation. The reason that we're doing this is because now this left-hand side is a perfect square and factors really nicely. And in fact, this is always going to be x plus b over 2, and b over 2 is just 2 squared. Again, that's just x plus b divided by 2. The right-hand side, I will simplify to 5. And now, this is an equation that we have seen how to solve already. Something squared is equal to 5. This means that that something is going to be equal to either the positive square root of 5, or x plus 2 will be equal to negative square root of 5. And now I can solve for x in both situations. I will subtract 2 from both sides of the equation to get x by itself. So x will either be equal to the square root of 5 minus 2, or if I subtract 2 from both sides over here, subtract, I'll have x is going to be equal to minus the square root of 5 minus 2. So we have our two solutions to our quadratic equation. Again, this is completing the square. So let's do this one more time. I have 2x squared plus 3x minus 4 is equal to 0. I've got a quadratic equation. If I'm asked to solve this by completing the square, I need that the number multiplying the x squared is 1. So how do I get rid of a 2 when it's multiplying something? I divide. So I'm going to divide both the left-hand side and the right-hand side by 2. So when I divide a bunch of things added together by 2, I can distribute. So 2x squared divided by 2 is x squared. Plus 3x divided by 2, well, that's the same thing as 3 halves x, minus 2. 4 divided by 2 is 2. Notice that 0 divided by 2 is just 0, so nothing changes on that right-hand side. Now, if I go through, I see that A, what's multiplying the x squared, is 1. B, what's multiplying just the x, is 3 halves. And the last term, C, is going to be negative 2. So, first and foremost, to complete the square, I have to get the x squared and the x term by themselves on one side. So I will add 2 to both sides. So after canceling out the minus 2 and plus 2, that will go away, and on the right-hand side, I'll just have 2 by itself. Now I can complete the square. So what I need is b divided by 2 squared. So again, 3 halves. Oops, I need to write a couple more things. B itself is 3 halves, and I want to divide all that by 2, and I need to square it. Again, I'm taking a fraction, and I'm dividing it by a number. I'm going to turn that number into a fraction itself, and instead of dividing by a fraction, I'm going to multiply by the reciprocal. So instead of dividing by 2, I will multiply by a half. And again, multiplying fractions, multiply the top, multiply the bottoms. Can't forget that I'm squaring everything. This doesn't simplify anymore, so 3 squared is 9, divided by 4 squared is 16. So to complete the square, I add this to both sides. So I add 9 over 16, and whatever I do to one side, I have to do to the other. And then what I notice is that this left-hand side is a perfect square. This is exactly what I wanted to happen. So this is going to be x plus b over 2. So 3 halves divided by 2, we said was 3/4. Quantity squared. And then I have this. So in order to consolidate, in order to simplify this, I'll turn 2 and I'll write it as 32/16. So that 2, which is 32/16 plus 9/16, 32 plus 9 is 41/16. So ultimately, running out of space on this page, so zoom down. Again, in order, so to solve this, we'll use the square root principle, and to say that, okay, if I have something squared is equal to 41/16, that something is going to be equal to either plus the square root of this number, or it'll be equal to negative the square root of this number. And let's simplify this down. If I take the square root of some fractions, of a fraction, I'm just taking the square root of the top and the square root of the bottom, but the square root of 16 is 4. And again, the square root of 41/16 I already have written over there. I just have to remember the negative sign. And then I have x plus 3/4, so I will simply subtract 3/4 both sides to get x is equal to the square root of 41/4 minus 3/4, or the same thing over here. X is equal to negative 41/4 minus